Okay, so in the previous video, right, we discussed about the composite function, and then I told you that in A-level syllabus, right, they actually will test you something extra, lah. Right? They actually try to bring in the concept of domain and range for the composite function. Okay, so to test you on that, lah. All right. So here I select two questions from the past exam paper, and then we'll discuss all these now, lah. All right. Okay, so again, just to recall back, so in the previous video I showed you, right, for the composite function of f composite g, when you want to draw the arrow diagram, you look something like this. Okay, so this is domain g, this is the range of g, and after that, this is domain f, and this is the range of f. So from here, there's one important information. All right, so from here, you know that for the composite function of f composite g, generally the range of g should be equal to the domain of f. And then in the exam, they will sometimes they will ask you to link this result or this information with the question that they want. All right. Okay, so we'll try to discuss two examples here. Okay, so please remember this, the range of g will be equal to the domain of f for this function, for this composite function. Okay, if g composite f, then it will be a bit different. All right. Okay, so you need to know how to draw the arrow diagram correctly and how to get this information correctly. Okay, so now let's have a look for for one example here. This example. Okay, so generally this example I take it from May, June 2016, and then paper 1-3. So this is question number 10. Okay, so actually this question got more than 1 and 2, got part 3 and part 4, I think, but I just cut it short to only the part that we want to discuss. Okay, so if you look at this question, here they tell you that the function f is this equation, and it is x greater equals to 0. Function g is ax squared plus b for this one. Okay, so where a, b, and q are constant, so the function fg is this, and x is smaller or equals to q. Okay, so first they actually want you to find out the value for a and b. Okay, so to find the value for a and b, I don't think that it is hard. All right, so what can you do is you try to use a f composite g. Then you try to use this information, and then maybe you compare left and right hand side answer, then you can get the value for a and b easily. So maybe you can try now. Okay, so fgx equals to 6x squared minus 21. Okay, so what is the gx? So gx is ax squared plus b is equals to 6x squared minus 21. So for here, this part, you will know that you have to substitute ax squared plus b into the function f. So if you substitute it, you will have 2, and then you substitute ax squared plus b, all right, and plus 3. And it is equals to 6x squared minus 21. Okay, so maybe you can try to expand everything. So if you try to expand everything, you're having 2ax squared plus 2b plus 3, and it is equals to 6x squared minus 21. Okay, so once you solve it until here, then what you can do is that you can actually try to compare the value of the left hand side and right hand side. So if you look at 2ax squared, you can compare it with 6x squared. Therefore, 2a is equals to 6, and a, you will get a value 3. All right. Okay. Then next, you can compare the constant term with the constant term. So if you look at 2b plus 3, okay, so I hope you can see this 2b plus 3, you can compare it with negative 21. So 2b plus 3 is equals to negative 21. 2b is equals to negative 24, and therefore the b is negative 12. So by comparing left and right hand side, you will be able to get the a and b, the values for A and also the values for B. Okay, so this part is not hard, nothing special. Okay, you can do it on your own also. Then after that, for part number 2, they have to find the greatest possible value of Q. So actually, what is the Q here? So if you look at this one, the Q appear in two parts. It is actually the domain of F composite G. It is also the domain of function G. Okay, so again, when because you didn't see any keyword here, they just want you to find out the value of Q. Okay, so a lot of students, they are like, hey, I don't know actually how to start because it is related to domain. And then last time you didn't learn the concept of domain and range yet, right, in your secondary school. Okay, so usually it's like that. When they ask you to find the value that is related to domain, okay, or something, and especially this is a composite function, then you have to use the result that I asked you to remember just now. Okay, but before that, let's start. Do you know what is this? This is actually, okay, so maybe I can write out first. You should know that this is the domain of G. What is this? This is the domain of F. Okay, and then what is this one? 2x plus 3. Fx is y, right? So y equals 2x plus 3. So actually, in short, you should know that this is actually part of the range of F. But the range of F should be a value. The value actually you can get it from this equation. Okay, if you know how to substitute the value of x or whatsoever. All right, so in short now, the formula here is actually the range of F. Okay, and then in short, this is also the range of G. But in exam, you cannot straight away write out 2x plus 3 is the range of F because in exam, they will want a particular value. Okay, so that particular value, you can get it from 2x plus 3. Okay, but now in general, you should know that 2x plus 3 actually is part of, it belongs to the range of F. So this one, it belongs to the range of G. Okay, so if I want to find the domain of G, right? Sorry, I want to find the Q. Q is either the domain of G or maybe the domain of F composite G. So this particular question, it is related to composite function. All right, so if let's say I want to find out anything related to domain or range, then I can suspect or maybe I can consider to use this result. Okay, so for any composite function, F composite G, the range of G should be equal to the domain of F. So now, you can use the result for the composite function F Gx. You should know that the range of G is equal to the domain of F. How you know about it? You have to memorize the result here that I showed you just now. So usually for me, I will memorize the arrow diagram. Then from the arrow diagram, I will roughly know, okay, what is the range equals to what function domain, something like that, okay? So for here, you are having range of G equals to the domain of F. What is the range of G? So the range of G will be x squared plus b. So what is your A? A is 3. So 3x squared plus b means minus 12. Okay, so what is the domain of F? So the domain of F is x greater equal to 0. Okay, and now you want to substitute the x by using the range of G. Okay, so the range of G will be greater or equal to 0. Okay, because the domain of F is greater equals to 0, right? Therefore, the range of G is equal to the domain of F. Therefore, you are having 3x squared minus 12, which is the range of G greater or equals to 0. Okay, follow what you have for the domain of F. All right. Okay, so after you get this answer already, then what are you going to do is like you can simplify it, become x squared minus 4. Okay, then x squared minus 4, because this is an inequality, you cannot straight away solve it, move the 4 over and so on. So what you need to do is I have to draw the number line. So when you factorize it, you're having x minus 2, x plus 2 greater equals to 0. So having two values here, negative 2 and also positive 2. Both, I need to draw the line to the right hand side. And then this is plus, minus, plus. Okay, so because on this question, they're asking for greater equals to 0, that means they want positive value. So you should have this answer and this answer. When you write out the answer, right, it will be x smaller equals to -2 and also x greater equals to 2. Okay, so now they are asking for the value of q. So how can I know what the value of q, which is the correct value of q, right? So you see, what they want is x smaller equals to q, right? So you should compare it with x smaller equals to -2. Smaller compare with smaller one, you cannot compare it with the larger one, right? So if you do the comparison here, then you should know that actually what is the value for q? So the value of q should be -2. Okay, so this is how we do this question. All right, so again, every time or every year when I discuss this question with students, they will always make noise on like, hey, how I know that in exam I should use this concept. Okay, so now I'm teaching you. All right, so once you have the idea on this kind of question already, then in the future, when you look at it, then roughly you will know. Okay, so again, when are you going to use this result? Okay, this result is because of you're having a composite function and they're asking for the domain and range that related to the function here. Right, so you should suspect that you might need to use this result to get an answer. Okay, so again, this question, it looks a bit tough is because of, first, you need to apply a new concept here, and secondly, you need to solve quadratic inequality. So again, this is from chapter 1. All right, so now I hope that you can see how they link actually all the chapters together. Okay, so again, for those who first time look at this question, you might feel very lost. Okay, so you try to understand this slowly and try to get the idea here. Okay, because you never seen this question before. All right, by using all the concept of domain and range, therefore you might find out that it's a bit hard for you to understand or make a separate. Okay, so after you try a few more questions related like this, similar with this, then you'll find out, okay, the idea is that, okay, the main thing is the range of G is equal to the domain of F. Okay, so this is one of the questions that I think is quite worth for us to discuss. So maybe you can put big star here or anywhere in your notes, all right, so that you can make a simple revision before you go into the exam hall every time, all right? Okay, so let's continue. I found another example which is related to the same style also. Okay, so this question particularly is from October, November 2018. Okay, then it is paper 1-3 and it is question 11. So at first, they are having part 1, part 2, and part 3 at the beginning. Okay, so but to me, it is not important. We'll discuss part 4 only with you. Okay, right, so you can see just now it's 2016, this is 2018, right? So in this few years, actually, they started to ask this kind of question. Actually, earlier year, they don't have this kind of question one. All right, so make sure that you maybe need to put some effort in this kind of question. Right, okay, so let's start. We have a function f. This is the domain of f. We have the function g, and this is the domain of g. Okay, so now k is 1. So that means maybe this one, or you can straight away change it up. X smaller equals to 1. Okay, they want you to find the largest value of the constant p. So the p is actually the domain of g, which allows the composite function. So here they also give you the keyword. They actually want you to form the composite function. And they want to know if they want to form the composite function, what is the value of p that they should have. So you see the word composite function, and the question, the p is related to the domain or range in our composite function. Then generally you should use the idea that we learned just now. Okay, so again, if you want, you can try to rephrase it out. What is it? This is the domain of G. This is the range of G. Okay, so this is the range of F. So this is the domain of F. So again, in exam, right, when they're asking for the range of F or the range of G, you cannot straight away write the equation for them. You have to substitute some value into the equation, or maybe you have to draw the graph, then only decide the range. The range should be in number, cannot be in formula. Okay, right. So, but for calculation part like this, that we just assume that the range is like this. Okay. Then now, first I want to find a P, right? Okay, so I'm having the composite function f composite g. So that means the range of g should be equal to the domain of f. Correct? Okay, so what is the range of g? X plus 3. What is the domain of x? Domain of f? X smaller than negative small equals to 1. X smaller equals to 1. Therefore, you are having the range of g smaller and equals to 1. Okay, so what's the value of x that you should have? So 1 minus 3 become negative 2. And you compare the value here, x smaller equals to p, compare it with x smaller equals to negative 2. So very easily you will get the answer which is p equals to negative 2. Okay, so again, we are using this result here. When do we use this result? They are asking about the fg and also the value that appear inside the domain or maybe the range of the f composite g. Alright, so here we get a p already, and they want you to find the fgx. So to find the fgx, I think it's very simple already. So fgx is equals to what? Your gx is x plus 3, right? Okay, then you substitute the x plus 3 into your function f. So you're having 2, then x plus 3, and you square it, then minus 12, then x plus 3, and then plus 11. Okay, and after that, you just try to expand everything. But I didn't have the answer with me, so I will expand it for you. So 2x squared, 6x, 9. Okay, so I'm having 2x squared plus 12x. Then this one should be negative 25, if I'm not mistaken. Then after that, if I further simplify it, I will have 12 minus 12 becomes 0. So 18 minus 25, I will have negative 7. Correct? Alright, so correct me if let's say I did any careless mistake. So temporarily I get this as the answer, 2x squared minus 7. Okay, alright, so again, these are the two examples with something new being introduced in the A-level syllabus. So please make sure that you know how to link the domain and range that when you're having a composite function. Alright,